Hello, my name is Ryan Green from Green HSE, where we provide transformational EHS tools for you. Today, we will cover the key points of a root cause analysis. I feel it's important to cover the root cause analysis because in my career, I've seen many companies not provide adequate root cause analysis. I've sometimes seen root cause analysis not be thorough enough and only scratch the surface of an issue. Sometimes I've seen root cause analysis not being completed at all, and other times I've seen companies only prescribe to one kind of root cause analysis and not provide different sorts of root cause analysis options for people to use. So today we will cover different kinds of root cause analysis, the importance of root cause analysis, and how to conduct one. A root cause analysis may be conducted for many reasons, possibly safety or environmental incidents or issues, quality issues, productive issues, or just to find better ways to manage the company. The goals of a root cause analysis are to identify underlying problems, take corrective action, and prevent reoccurrence. Success in an RCA depends on maintaining focus on all three goals throughout the analysis and implementing the process. Each step builds upon the previous one, creating a comprehensive approach to problem solving that leads to sustainable improvements. By the time you start your root cause analysis, you should already have all your documentation ready. Your first step is to define your scope. Your scope may be limited to an isolated occurrence, or it may expand to self-systemic issues. This could be a minor nonconformance, near miss, or first aid injury, or this could be major nonconformance, potential for serious injury or death, near miss, or an OSHA recordable injury. Next up is to assemble the right team. The team may be different than those who collected the initial evidence. You may need to pull in some more subject matter experts or excuse members who have completed their part of the work. And then set the timeline expectations. Some root cause analysis may be simple and not need more than one or two people and may take just a few moments to conduct, some without the need for tools. Others may require multiple experts and tools and may take days or even weeks to complete. However, it is important that all root cause analysis be completed promptly. Next, let's talk about the step-by-step approach to an RCA. Personally, I prefer to be more methodical about my RCAs, so I use a DMAIC or a PDCA method. DMAIC is define, measure, analyze, implement, and control, whereas a PDCA is plan, do, check, act. Sometimes I'll use a little bit of elements from both. Sometimes I'll use maybe a different continuous improvement or Six Sigma method. Sometimes I'll just use a simple method like a 5Y. So the first thing I like to do is define my problem. I clearly identify and describe the issue. I create a clear description of the incident or nonconformity. I determine what the outcome or impact was. Maybe it was an injury, regulatory penalty, missed deadline, or a lost contract. This is my problem statement. Next, I collect and measure the data. I gather all relevant information related to the problem. If this is a systemic or an ongoing issue, I measure it. So I would measure how many occurrences, or what is my injury rate, or how much time or money has been lost, or how much productivity has been lost. I identify the possible causes. So this is where you use your root cause analysis tools like your 5Y, your affinity, your brainstorming, fishbone diagrams, FMEAs, or just culture algorithms to explore those potential factors. And we will go over some of those tools later on. I believe there is no single tool that is best for all RCAs. I believe that we can use multiple tools. Lastly, we're going to analyze our causes. We're going to narrow down that list to identify the most likely root causes. All right, so it's important to also choose the method for your RCA. As we discussed, there are many different RCA methods. There are 5Ys, 3x5Ys, fishbones, FMEAs, post-incident decision trees, human factors analysis, or a combination of all of them. You can also use different continuous improvement methods like affinity diagrams, Kaizen, and Pareto charts. Next, think critically. Conducting a thorough root cause analysis requires experience and discipline. So don't be discouraged if you don't get it right the first time. Keep on trying. Dig deeper than surface level causes. Keep an open mind and don't stop at the first explanation. For example, if a machine malfunctioned, ask why it malfunctioned. Maybe it was a lack of maintenance or faulty part. If a worker made a mistake, investigate why that mistake occurred. Was it inadequate training, unclear instructions, time or pressure? Ask why that happened as well. Do not accept that this was a fluke, accident, or incident. Next, consider multiple factors. It could be equipment, environment, people, management. They may all contribute to the incident. An incident is rarely caused by just a single factor. You can use a fishbone diagram or similar tool to systematically brainstorm potential contributing factors. Consider human factors as well, such as fatigue, distraction, or lack of knowledge, environmental factors like poor lighting, hazardous materials, and equipment factors like malfunction or improper design. And you can also identify management factors like inadequate safety procedures and insufficient resources, and also dig deeper into those as well. It is important to avoid blame in your root cause analysis. Focus on the systemic issues, not individual fault. The goal is to prevent future incidents, not to assign blame. Focus on system failures rather than individual errors makes the investigation more effective in revealing underlying problems and preventing reoccurrences. Document facts objectively and avoid making any value judgments. Avoid going down the rabbit hole. This can be very difficult as well. During this phase of the investigation, it's crucial to avoid getting sidetracked. One can focus too much on one factor and miss out on others. This is especially true when confirmation bias is present. If needed, assign a subject matter expert to investigate a specific factor and then report back. Lastly, identify the root causes. Determine the underlying issues that led to the incident. The root cause is not just the immediate cause, but the underlying reason why the incident occurred. Progressively drill down to the root cause. Once identified, focus on developing corrective actions and address it directly. Here are a few quick tips for pinpointing the root cause. Trace originating causes. Isolate the few vital originating causes to target for correction. Consider multiple factors. Recognize that complex problems may have multiple contributing root causes. You may need to use a fishbone or other root cause analysis tools to help you find those multiple factors. Differentiate causal factors. Distinguish between direct contributors and the underlying deficiencies. Now we will discuss popular RCA tools and the pros and cons of those tools. I believe there is no one-size-fits-all tool for finding a root cause. A toolkit approach creates autonomy in problem solving. Some of these tools may include your 5Y or 3x5, a fishbone, fault tree analysis, Pareto, and other charts, failure modes effects analysis, just brainstorming, just culture algorithm, or human factors analysis and classification system. Of course, there are tons more tools that can be used. These are the tools that I prefer to use and I've used the most in my career. Perhaps one of the most widely used techniques, and certainly one of the more easier techniques, is the 5Y. First, we start with our problem statement that we discussed earlier, and then we ask why. And we keep asking why. We can ask why 5, 6, maybe 7 times. Usually we get to the root cause by about 5 times. Now it's important to remember that there sometimes may be extra factors involved, and this is when we can split it out to a 3x5Y. Now, although a 5Y is very widely used, there are some limitations. Let's start with the advantages first. They are simple and easy to use. They don't require a whole lot of training. They're cost effective and quick to implement. It encourages deeper analysis beyond surface symptoms, promotes team engagement and collaborative discussion, and helps avoid superficial quick fix solutions. I also see 5Ys used in a lot of safety software. However, there are some limitations. They may oversimplify complex problems with multiple variables. They're subject to an individual bias and perspective. There's limited scope for comprehensive system analysis. They can lead to incorrect conclusions if not properly applied. and they require skilled facilitation for effective implementation. While the 5 why technique offers a straightforward approach to root cause analysis, its effectiveness depends on proper application and understanding its limitations. Now let's cover the fishbone diagram. This is one of my favorite tools to use. They create an intuitive visual roadmap of multiple categories of influencing factors, and they help group factors into standard dimensions like materials, machinery, staffing, and methods. So if you have multiple factors, it really helps organize those thoughts. Of course, there are advantages and limitations to using a fishbone. Visual representation makes the relationship between factors easy to understand and identify. They encourage team participation and diverse perspectives through collaborative brainstorming. They provide structured approach by categorizing causes into manageable groups. They effectively identify root causes by systematically exploring contributing factors, and the simple concept and design make it accessible to a wide range of users. However, there are limitations. They may oversimplify complex issues with numerous interrelated factors. They lack quantitative analysis, making cause prioritization difficult. Can be influenced by team member biases during brainstorming. And creating detailed diagrams for complex problems is very time consuming. They cannot fully illustrate complex interaction of temporal causalities. A couple other tools that can be used is your failure mode and effects analysis and the fault tree analysis. Now these are more proactive mitigation tools that help develop controls and contingencies to avoid incidents before they occur or future incidents after one has occurred. A fault tree analysis, or an FTA, is a systematic method that maps system failures to identify root causes and prioritize solutions. They are ideal for analyzing complex system interactions. A failure mode effects analysis, or FMEA, is a structured approach to identify potential failures and assess risks through team-based evaluation and prevention planning. Now let's look at some advantages and limitations to these two tools. Both of them are very good at visual representation. They're clear graphical display of failure pathways. They have dual analysis capability. They can do qualitative and quantitative assessments. Effective communication, visual format helps explain risk to stakeholders. They can analyze complex systems. They have a proactive approach instead of a reactive approach, and they use a collaborative process. However, there are those limitations. I think one of the biggest ones is the data dependencies. The success of these relies on accurate data and can vary with team experience. Many teams don't have experience using a fault tree analysis or an FMEA. There's assumption constraints. They are very resource and time intensive. They can have a limited scope, and they can be difficult to manage, interpret, and use by those who are not experienced. Next, let's discuss a few brainstorming and visual chart tools that we can use in our root cause analysis. It's important to remember that these should not be the only tools used in your root cause analysis, but help to aid that RCA. The first is a Pareto chart. A Pareto chart could help identify the most significant issues. It doesn't show the cause, but provides important data to measure that problem. The next is an affinity chart. Affinity chart is a tool that organizes those ideas into groups based on their relationships. They can be used in your fishbone diagram. However, affinity charts can be purely subjective to individual experiences. And lastly is brainstorming. Brainstorming is a way to get a group together to identify ideas in a minimum amount of time and foster individual and group creativity. However, it's important to remember that brainstorming can cause groupthink and causative factors could be missed. Another great tool that can be used is the Human Factors Analysis and Classification System, or the HFACS. This tool is based off of James Reason's Swiss cheese model. It provides a systematic framework for investigating human factors. The HFACS framework describes human error at each of the 4 levels of failure: organizational influences, unsafe supervision, unsafe acts of operators, and preconditions for unsafe acts. Much like the fishbone diagram, this sorts events into different categories and helps find different factors into those categories. I typically use the HFACs for identifying root causes for multiple injuries that have occurred. Maybe a department has been experiencing a increase or an uptick in injuries. This is where I use the HFACs, especially if I'm finding that other tools aren't working. I start to look at the human factors, and this will help identify some of those factors. Finally, we'll cover the just culture algorithm, or as some call it, the post-incident decision tree. The just culture algorithm is a scientifically valid model that helps organizations evaluate employee behavior in alignment with their values, guiding leaders through consistent accountability decisions. After the RCA process, it may be used to determine the accountability while reducing blame culture. This should be used as a tool to supplement the RCA and not a tool to be used solely for the RCA. It is a structured approach to evaluate conduct after investigations, helping differentiate between individual and organizational accountability. It categorizes incidents into human behavior, at-risk behavior, and reckless behavior, enabling appropriate responses to each type. It creates an environment where employees feel secure while implementing systems to prevent future errors and improve procedures. I want to thank you for taking this webinar. It's been a pleasure. It's important to remember that there are many tools that can be used for root cause analysis. Do not prescribe to just one tool. Use all the tools at your disposal and also identify other tools that can be used. Consistently practice root cause analysis to get better. It's important to keep doing them and learning and growing with the root cause analysis. Thank you, and we'll see you on the next one.